Hi everyone, today's topic is how to find the slope of a line of best fit. You do not need to write down everything that we'll cover in this video, but be sure to jot down important information, at least one example of each type of problem that we'll cover. Also remember that you can pause the video to jot down important notes, rewind to view information again, and fast forward if you think you got it. But be careful and don't fast forward so much that you miss out on something important. So let's start with reviewing about the line of best fit. Last time we talked about how the line of best fit should go through the scatter plot, and it's kind of showing you the general trend of those dots. So it's what you eyeball and you find is the best fitted line. So you should remember that the steps to find the slope are that you first have to find your pretty points. So you're going to find two pretty points. And then once you find those pretty points, and what we mean by pretty points is ones that line up with two numbers on both sides, you're going to figure out your rise and your run, and you're going to divide them because slope is rise over run. And remember, slope tells you how much it's changing, so the rate of change. Be sure to have this jotted down in your notes to reference. It's been a while since we've talked about slope, so this definitely needs to go in your notes for today. Okay, so let's start with this problem on Khan Academy. It says that the scatter plot below shows the relationship between years of education and income for a representative sample of adults. So years of education and income. So they're comparing to see if they're related to each other, if they're correlated. Which of the following is the best estimate of the average change in a person's income that is associated with going to school for an additional year? So when they say the change in the person's income that's associated with going to school for an additional year, change tell you that they're asking for slope. And remember, slope is rise over run. And they said a person's income, so the money they earn, associated with going to school for one more additional year, so per 1 year. So they're basically telling you the rise over run in the problem. The change is the slope. Person's income, money, that's associated with going to school for one more additional year, per 1 year. Money changing. How much it's going up for every additional year. So there's always going to be a lot of clues in your problem that kind of helps you figure out what it is they're asking. So now that we are looking at our scatter plot, we're going to need to figure out a line of best fit. Now keep in mind this is estimating the slope of the line of best fit because the person sitting next to you may have drawn a slightly different line of best fit. So that's why they said to estimate it. Not everyone's going to be exactly the same, but everybody's line of best fit should be around the same. So I actually can't draw past this point, but I'm going to show you again that we are drawing that tunnel to kind of frame where our line of best fit would be. Let me make sure it's more this way, because it's going down this way and this way. Okay, so that means that my line of best fit is going to be somewhere in between there. So it's going to be going in this direction. Okay? And I can't draw further down here or else I would continue. But I actually don't need all that. With this, I already have enough information to find two pretty points. Looks like I have a pretty point here and a pretty point, let's say, right here. Estimated. Notice how my two pretty points are not points on the scatter plot. I found 2 points on the line that I drew. So both these blue points are not original dots on there. Sometimes people get confused with that. They think that they have to choose a dot that's already there. No. Those are data points. We made up our own line of best fit. So remember, on our line of best fit, we're choosing 2 pretty points on that line. Okay, so it's like once we figure out the line of best fit, we're ignoring all these other dots and we're picking our own 2 pretty points. Okay, so we want to know the change of income, the money, so our rise needs to be calculated. And then that's per 1 year. So then we need to figure out our run. So we're basically figuring out the rise of our run with this triangle from these 2 pretty points on our line. So this is going from 60,000 to 80,000. So if I make a jump from this pretty point, which actually lines up perfectly with 60,000 to going up to 80,000, it's going up 20,000. Okay, and then if I'm moving 1 over to the right, which is also positive because I'm going up, I'm going plus 2 years. And this is plus $20,000. So I'm just making sure that my units are correct. This is dollars, so it's plus $20,000. This is years, so it's plus 2 years. And this is 2 because it's going up by 2, so you have to be careful there. And now to find slope, it's rise over run. We do have to divide that. They do want per 1 year. If I divide it to 20,000 divided by 2 is $10,000 per 1 year. Okay, because it's like we divide it and it's going to be 1 year because both the top and the bottom are divided by 2. All right, so this is our slope, about $10,000 a year. So what this information is telling us is that according to their studies, for each additional year of education that you get or attain, you will tend to, because remember I'm using careful language, you tend to earn an additional $10,000 for the extra year of schooling that you went through. Obviously, that's not the case for everybody. Sometimes you have, let's say, this person who went through a lot of schooling but ended up not making as much money as the other people who went to 17 years of schooling. So there's always going to be some outliers. Or you might have somebody who only went to like 9 years of schooling, but they're earning just as much as somebody who went through 20 years of schooling. So that's why we use the words tend to. It doesn't apply to everybody, but it's the general trend. All right, so $10,000 per year. Which one's the closest? It looks like the 7,000. No sound, but you get my point. 7,000. These other ones just look completely wrong. You could have gotten rid of A and B because there's no way you would just earn $1 more or $2 more, especially when the scale is in the tens of thousands. So it was always going to be between the last two. All right, let's try another one. So this problem says, a company that makes an exercise machine asks some of its recent customers how long they have owned their machines. They want to know how long they've owned it and how many hours per month they currently use their machines. So they're trying to see if there's a relationship with how long they've owned the machines and how often they use it. So I'm probably thinking if you just bought a machine, you're going to use it a lot. And maybe over time, you're like, oh yeah, I forgot about that. Kind of like new clothes. You like to wear it as soon as you get it. But then after a while, it gets kind of old. So let's see. There is like a downward trend. Okay. They want to know which of the following is the best estimate of the average change in hours of exercise per month that was associated with 1 month increase in ownership. So again, it's an estimate, so it doesn't have to be exactly what they found here, whatever's closest. Average change. Change again tells you slope, which is rise over run. so they should tell you what that is. Hours of exercise, so exercise hours, exercise time, how about that? Per month, that was associated with 1 month increase. So they want to know how much exercise time for every 1 month increase. So each additional month that you have this machine, how does the exercise time change? Okay, so go ahead and pause the video and try this one on your own first. All right, so this one is a pretty strong, it looks like negative correlation, because as the ownership is going up, the use is going down. This person got it for 11 months and is only using it twice per month. This person just got it pretty much and is using it 9 times per month. Oh, sorry, 9 hours per month. So it's a pretty, like I said, strong correlation. I wouldn't even really have to draw my tunnel. I'm just going to draw a line kind of through the middle-ish area. I know my line is a little crooked, so let me switch that. Doesn't matter too much, but just kind of bothers me a little. Okay, so my line is gonna just try and go through the general trend. I feel like it's a little bit high, but again, this is just an estimate, so it's fine. Once you find your line, you're going to find 2 pretty points. Here's a pretty point. Remember, it doesn't have to be an actual dot on the line. And it looks like this could be another pretty point. It doesn't have to be precise. We want to know how much exercise per month changes for every 1 additional month ownership. So my rise is going to tell me the exercise time. It's going up from 7 to 8.5. So that means it's going up from 7 to 8.5. That means it's going up 1.5. And then for the ownership, it's going from 4.5 backwards. 4.5 backwards to this point lines up with 3. So it's going down 1.5. Okay, so the slope, M, is equal to the rise of 1.5 hours of exercise for every, let's say, decrease of 1.5 ownership month of owning it. I do have to divide them. 1.5 divided by 1.5 is 1. So we're going to have 1's on top and bottom because they're both being divided by 1.5. I do have a negative. I'm going to put that negative on the top. So this is hours of exercise. And on the bottom, it's 1 month ownership. So what this means is you use your exercising machine 1 hour less for each additional 1 month ownership. So every month longer that you own it, you exercise it 1 hour less per month. So it seems like according to this trend, after a year, you've pretty much forgotten about your machine. You're like, oh yeah, that thing over there. According to their study, the information they gathered. Okay, so it looks like it's 1. The slope is 1. Let's see, what's the closest to 1? All right, well, definitely not 5. Definitely not 3. They're all negative, which is good. That's what we want. Because negative, let me get rid of this. Okay. Negative means that it's showing people are exercising less. So they're all good with the sign. This is -3/4. If you wanted to change it into a decimal by dividing 3 and 4, you get -0.75. And then this one's about -0.3. So the closest one would be C. And again, they probably just use a different line. but it is the closest one. Okay? So yours does not have to be the same slope as theirs, but you're always going to draw a line, find two pretty points. Remember, those points don't have to be on a point on the actual scatter plot, and then do your rise, up how many, and your run, over how many, divide them. Let me know if you have any questions as you work on these problems, and have that slope formula handy, and I'll see you in class.